Hello, thank you for attending our low-cost, compact, high-throughput, automated sample concentration and evaporation webinar today. This is Tom Hall from Fluid Management Systems, and we're going to be speaking about our SuperVap concentration system, which has been around for quite some time, but we've made some major improvements to that system. We're just going to do a quick company overview first. Then we're going to cover the SuperVap. We're going to show you a lot of the new screens, and then we'll show you some data at the end, and then we'll take any questions through the chat. Fluid Management Systems was founded in 1986. Our focus since that time and to this date has been automating the sample process and hyphenating as many of those we can, combining those techniques to eliminate error, so on and so forth. The markets that we cover are agricultural, environmental, clinical, food and beverage, pharmaceutical, and petrochemical. Everything here is proudly made in the USA in Billerica, Massachusetts, at our manufacturing facility. That's also our headquarters. Where we have our laboratory and all manufacturing. These are just some of the valves that we make that are patented, 6-way and 2-way valves. These go into our systems for extraction and sample cleanup. All of our consumables are manufactured in a Class 1000 clean room. Just briefly cover what we, for those of you who are not familiar with us, we make a wide variety of and range of solid phase extraction systems. So those are basically systems that are used for extracting liquids, so like drinking water, wastewater, serum, juice, etc. They're made for handling clean samples, dirty samples. They can do multi-cartridge cleanup. So for example, the one on the left is called the Econotrace. These are all modular. They can expand out to 6 or 8 modules that can do 6 or 8, up to 6 or 8 extractions simultaneously. So the Econotrace is for drinking water, up to 8. The TurboTrace is handling drinking water or wastewater, up to 8. And then the Turbo ABN is for doing 625, 8270, 608. Doing the sample extraction and cleanup. They require multiple cartridges, and they're also capable of doing all of your drinking water and wastewater methods. Then we have the Turbo PFC system for PFAS, PFOS analysis. All of these units can be made in to be PFAS and PFOS sample prep systems very easily. They contain no Teflon. And then the NanoTrace on the end here to the right, that's for very small volume types of extracts. Then on the solid side and the semi-solid side, we have the pressurized liquid extraction system, also known as the PLE. And again, you can have up to 8 of these modules. What you're looking at here is one module. So once you have this controller, this one module will do one sample at a time. You can have up to 8 of these connected to each other to do 8 in parallel. And if you notice here, we have this very small instrument connected to it. That's the SuperVap, the concentrator that we're going to be talking about today. All of the FMS equipment, and including the ones in the previous slide, one of the best things about the SuperVap is it can be connected to work automatically with all of our automated sample prep equipment, taking out a transfer step and eliminating a lot of error. So, and again, a totally closed environment at that point. Here is our automated sample cleanup system for dioxins, PCBs, PBDEs, PAHs, pesticides. This is would be an EP110 or an EconoPrep. You can have up to 8 samples at a time. And again, this is showing a great example of nice connectivity that you have, seamless connectivity between the sample cleanup and the concentrator. So basically, these are going to clean up the samples, send the fractions directly to the SuperVap concentrator, and then the SuperVap concentrator is going to automatically blow down those samples to final concentration. And we're going to get into the SuperVap in more detail. So right here you can see this is the SuperVap concentrator to the right. It has a very large touch screen, easy to see. You can see that it's a very small unit. It's only 9 inches by 10 inches tall by 13 inches deep. So very compact, very small. You only have 2 gauges. You have a gauge and a nitrogen adjustment and a alarm reset button on the outside. One of the key things is that the SuperVap will directly blow down your sample into a GC vial. You then unscrew that GC vial and you're going to cap it and directly put it into your GC mass spec or your LCMS mass spec. So you're eliminating any transferring processes. And if you've been doing concentrations and extractions and so on and so forth, every time you make a transfer, you lose a couple percentage of analytes. That's just a fact. You can't get them all out. So by being able to keep them in the same vessel going directly down to the GC vial, we're saving those percentages, giving better, higher recovery results. So we're going to talk a little bit about sample handling and processing here. The system that we're showing right now to the right is a large volume concentration system. It concentrates and evaporates up to 6 samples at a time. The sample sizes can be up to 220 mils. It's a 250 mil vessel. The highest we've run it at is 240, but you have to be very careful with that. It has automatic endpoint and nitrogen shutoff for each vessel. So in other words, as each vessel reaches its endpoint, it's going to shut off the nitrogen automatically to stop continued blowdown of that extract, therefore protecting against the loss of analytes in a very small size. Again, this is just a overview of all the different vessels we have. So here's a 500 microliter vessel. Some folks use this for, PCBs and other types of things where you're going to go down to 500 microliters. Then you have a variety of different GC vials here that are attached. This we can take 2 different sizes of GC vials, thread sizes. There are 2 basically that are out there on the market, and we're compatible with both. You just have to tell us which ones they are. And then you have the 1 mil nipple at the in the end, and that's more for your 1 liter SPE extractions that go down to 1 ml final endpoint. And again, we have a lot of folks like to use the direct to GC vial vessel. This is a really key feature for getting the best possible recovery results. Now we are going to talk about a smaller volume concentration. So the sample size or the extract size would be up to 50 mils. It's going to do 12 samples at a time. And again, it's very similar to the 6 position, where it's going to do 12 samples at a time. You have your automatic endpoint detection, nitrogen shut off for each vessel. Again, this is a great evaporator for your drinking waters and other wastewater types of methods. And again, really small. So you can imagine you could have two of these, which would give you a batch of 24 samples together in like a 18-inch wide across the bottom. So it takes up very little lab space. It's a closed system. We'll show you how we vent out the fumes in a minute, but it can be run outside of the hood, and all of our automated equipment can be run outside of the hood, and that's pretty key where lab's bench space is a high commodity in our lab world. And here's some concentration vessels for the smaller 50 mil vessels. Give you an idea, it's a 1 mil. Then we have several other types of specialized small volume evaporators, which come in 24 sample sizes, as well as 12 sample sizes. These do not have sensors in them. They're just you set a time for the length of evaporation. So you're setting a temperature and time to complete your evaporation. So these are the ones that we're talking about here handle up to 24 samples. They're 2 mil, 4 mil vial types of evaporators. We're going to talk about the evaporator for PFAS and PFAS, which can also do 15 mil plastic centrifuge tubes, 24 of them. You can also get this in glass centrifuge, for glass centrifuge tubes as well, and those are very popular. Again, just time, no sensor. You can evaporate up to 12 samples for 20 mil vials, the ACE 40 mil and 60 mil vials. For those of the folks out there that have ACEs and are looking for a better, more efficient, low cost, high throughput type of solution for evaporation and concentration. And again, a very small size. This is just a quick picture of all the different vessels that we can handle. This is a conical type of a 60 mil vessel. That would be in a 12 position type of a system as well. And again, we have the only concentrator that is specifically designed for the analysis of PFAS and PFOS. It has no Teflon, parts or tubing in it, and it blows down the 24 at a time to dryness. And this is showing the plastic centrifuge tube. So it's really good. A lot of folks are doing this manually. They're running lots of samples now for PFAS and PFOS, tens of thousands of them, and this is really a nice solution for that. One of the key things about the SuperVap is we don't use a water bath. Water baths cause problems to electronic sensors that are sitting in water and other in the water baths, as well as other electronics, because there's nowhere else to put the electronics but in there. So you have those electronics failing pretty regularly, and the SuperVap eliminates that. These sensors are out in open air. So you don't, and also the other thing is you don't have water dripping into the vessel from condensation hitting the top of the evaporator cover and then dripping back down in. When you have water in there, you're going to get lots of condensation. If you were to get condensation and you're in a severely humid area, we have covers that go over the tubes that eliminate that possibility. So they're Teflon covers that go on the top of the vessels. Those come standard with the SuperVap. So the The SuperVap's super easy to use. It really takes about 5 or 10 minutes to figure out how to use it. We do have videos, etc. But pretty sure that after you see this webinar, you'd be able to use it pretty quick. So it's a nice touchscreen programming. It's programmable from 0 to 100 degrees C, depending upon the model. It has they have endpoint liquid level sensors that detect when the desired volume is reached, and then it shuts off the nitrogen. And again, can be used as a timed endpoint as well. You'll see how that can all be easily turned on and off with this new touchscreen. So this is just a quick front view of the new SuperVap. One other thing I want to mention about the SuperVap, and I didn't cover that in a slide, is we've actually changed the heating elements in the SuperVap as well. So the ramp up of the temperature is much faster than it was in our previous models. So, as technology changes, we have upgraded that as well. So you can see here, just really 6 simple buttons. Editor is for obviously modifying, creating, and saving methods. Run is run the method, choose the method and run it. Configure, you're just gonna name your system and do some other very simple things there. There's a calibrate to go ahead and calibrate your high and low temperature to make sure that the system is operating at the correct temperatures. It comes from the factory calibrated, so that's not really something that you necessarily have to do often. It's probably something that you want to do, maybe once a year or something like that. Then you have the data log, which is basically saving the data from your run. So in other words, a point that's collected, it can be every 4 seconds, 10 seconds, whatever, of the temperature during the actual concentration or evaporation method. And you can see on the left-hand side, you just have your gauge that tells you what the nitrogen is set at. You have the nitrogen regulator in the middle. That is easily adjustable to turn up or down the nitrogen. And then you have an alarm which resets. You're resetting the alarm, which is when it gets to final volume, it's going to beep and let you know that it's finished. This is just a quick rear view of the SuperVap. You can see here you have a nice an SD card, which is just like using in a camera or a video camera or something like that. That stores all of your data. So you're going to push that in there. That's a very low cost SD. It holds hundreds of methods. Down here is where you turn on the power and the main heater. The SuperVap has 2 heaters. One heater is the main block, and then you have the lower heater, which is up here, which is the lower block, which covers the vessel taper to the beginning of the nipple. So when that nipple is actually sitting down there, the liquid in that is not in a heated zone. So that's pretty key as far as saving analytes and not blowing away your concentrated extract. And here you have your exhaust. So this is like a 2-inch hole with a very high-powered fan, which attaches to a vent hose, which you can run to your hood. We supply that with each SuperVap. And then you have your USB connector here to the left for downloading to PCs. Not many folks do that anymore. They usually just take the SD card out and copy it to their computer. Also, if you're having problems or something, we a lot of times will ask you to download your methods off that SD card and send it to us for us to review to see if there's anything that we need to do to fix that. So as you can see, the home screen is really straightforward. 3 or 6 buttons, 3 on each side. Doesn't really get much easier than that. And then over here, you'll see to the left, you have unit ID, and that's where in the configuration, if we had set a name, My Evaporator or Roots Evaporator or something like that, that's where that would show. And we'll talk about that as we go along here. So file storage, this is on your SD card, and this is where you can store up to 200 files, basically. And this is just showing you have a total of 7 here, up in the left-hand corner, real simple. And these are all the methods, basically, that have been created for this, on this system. SuperVap comes with standard methods like this loaded. So you'd have, I think it's 35, 45, 55, 60, 65, 70, like that. And so if you're going to create or select one of these or open it, you're going to select it here, and then it will pull it up on the system. Yeah, so selecting a file, again, just what we talked about. You're going to select the file that you want to run, and for this, for what we're doing here, we're going to set it to, we're going to select the either 55 or 50, I can't remember. Yeah, so it's 50. So when we're going to run a method, now we have it here, we're going to open it, and here you have, there's basically 2 simple things going on here. Step 1 is for 5.2 minutes, we're going to take the temperature to 46 degrees C. That's our preheat step. So there's no nitrogen or anything happening there. And you can see down here, I have 2 things happening. Real simple. I select time and I select heat. I save it and I'm ready to go. Or it's already been done. And so then it's just going to run. Then as it gets to the second step, this is where the evaporation is starting to happen. So it's automatically preheating your system, getting it ready to go. Then now we've got it set to the sensors down below that are on that nipple, measuring when the system is going to get to a half a mil in that GC vial or the nipple of the concentrator tube. The heat is on, so the heat's automatically coming on and off to basically keep the heat at the temperature that at 50 degrees that we want. We're in the auto mode, so you see all of the tubes here, and you see it in auto. They're all highlighted. And then down below here, we can see all of these 1 through 6 are highlighted. That means that these are all underway and not finished. So they're in the evaporation concentration process. This is just an example of, now we have some vials and positions basically finishing up. They've set off an alarm. So they're going to, trigger the alarm. We shut it off. We're going to pull out our vessels. So if you look here, you can see 1 is no longer highlighted and 3 is no longer highlighted because they're finished. You're not blowing down those tubes any longer. So off is 1 and 3. You can see here I'm at 52 degrees, so I'm a little bit above 50, but you can see my heat mode is not selected, and so we're just kind of running. We're just waiting for the other 4 tubes, 2, 4, 5, and 6 to finish running. The temperature plot is a really cool thing that the SuperVap has, and log, really a log, that other concentrators do not have. And it's really key because the only way to find out if something screws up on your evaporation is the heat's gone wild or there's something not, right with it. So here you can see the ramp up. It goes up, then it gets to its 50 degrees. So that's like at 10 minutes. So it's moving along here. You can see 10 minutes. I'm at 52 degrees. And that's starting to come down. So it'll get to 50. The other thing is if I'm looking and trying to see different things along that temperature curve, I can select this curve at any point. So for example, you can see this line going up and down. I selected that point, and it tells me that at 12 minutes and 48 seconds, my temperature is 49.57 degrees. And if I look, yeah, so that's pretty important. It's telling me exactly what the temperature is at each point. You also have manual operation here. So depending on what you're doing, you may get down to, a couple, you may have dirty samples, for example, that have defeated the sensor. So in other words, it's just going off because they're dark samples, and that, like a lot of wastewater samples, you can get that happen. So you want to go into manual so you can continue to blow it down to its final volume of 1 mil or half a mil. So in this case, we have tubes 1 and 2 selected for manual. It's just going to go with the heat, nitrogen. So that's what this is the nitrogen. And we're going to just run it and manually monitor that until it reaches the final volume. So it's a good feature to have. So we're going to talk about creating a data log and saving a plot. So these plots are the temperature plot log that we just showed you. So you saw that one of the 6 buttons had log on it, and one said data log. And so you're going to name here. You can set the time and so on and so forth. Name the plot or the data log. You could do 6/27/50, whatever, or 2022 or something like that, and just apply it. So this is every 4 seconds. It's taking the temperature, and you apply that, and then you come down and save it. It's going to save that file on your SD card for later storage for, ISO or other types of things to go with your actual chromatography results. So a very nice feature. So that's what that does. It's simple. This is all very easy to use. And again, 5 or 10 minutes, you're basically off and running. So here's creating or opening a file. I'll let Ruud talk about this a little bit, and then we'll move into data.
Yeah, so here we just think you have just a blank screen where you could type in the different steps and temperatures, etc. Of the program. However, it is usually easier to just take an existing program, which will be on the next slide. And as you see what we did here, we copied line number 2 using the copy function here into 3. And now you can just start editing. You could change the temperature, for instance, to 60. If you want to go to a higher point, there's a delete option, and also save. And here you can highlight, check the different tubes. So say that you only want to do tubes 1, 2, and 3 in this case for a 6 position evaporator. You uncheck 4, 5, and 6. And then it would not be heating those 3 positions, and it would just transfer and fill with the first 3 tubes in 1, 2, and 3. And again, here you have the mode for the time and sensor and for the heating. And you can save a method, typically usually with computer file saving. You can either save it and it will override the existing file. Excuse me, you can do save as and save it under a different name. Here's the system configuration. Tom already mentioned that. You can choose the name of your unit here. You can set the LCD timeout. I think you can go up to 90 minutes that your screen doesn't go dark. And you can also set a clock, or you can reboot the system here. That should be in a normal operations conditions, not really necessary, but there is that option.
And use as a slave over on the left, that's when you're connected to an automated FMS extraction system or a cleanup system.
Right, so
left.
right, you can,
And then
you
it's
can
gonna,
start it remotely
Yeah.
from either the power plant, the EP110, or an SPE system, or a PLE system. Yeah, I think
so very powerful, yep.
this is a vial evaporator. Thomas already mentioned those, so either it is for 2 mil vials, if you're just doing typically GC work where you want to blow down to 1 mil, or you want to go for dioxins and PCBs to maybe 10 microliters. But you can also, as the same interface on the SuperVap 24 for the PFAS, SuperVap PFC as we call it. And in that case, you would mostly use higher temperatures like 60 or 65, because the EPA methods, at least in the United States, like 533 and 537.1, they indicates, as far as I know, that the blowdown for PFAS samples should be at least at 60 degrees, and I think it says hot, can also be higher. But so that typically for doing a PFAS blowdown, you would use these higher temperatures, and you check on the right here, there's 4 rows of 6 vials each, so you can just program that in the file interface with this screen.
Right, that'll save nitrogen. We have a lot of people ask about that, yeah. Not all 24 vials running at one time. If you have 6, 12, 18, 24, you're just gonna select this over here, row 1, 2, 3, or 4.
Here we have the same vial interface. Now it is in the evaporation mode, so with the times, you have to realize that with these the 24 vial evaporators, there is no infrared built-in sensor, so everything is timed. So if you know approximately after trying it out when your vials will be dry, you can set up the time needed for that. And then again, you can just run either all the rows of so 24 evaporation modes, or you can just run 1 or 2 or 3 or 4 individually if you want to. And in this case, you can see the heat is on. Then the next slide, Tom has already mentioned this, once a year or when needed or whatever you want to choose as a period. Sometimes people have lab accreditation, like with ISO, which we already mentioned, which require that once a year you calibrate your system. You can take out the thermocouple that is inserted into the metal heating block, and you can calibrate it across the range of temperature that you're using. Lower temperature, usually ice in water, and very close to 0 degrees centigrade. And for the higher points, you can use boiling water. It isn't strictly necessary. I mean, if you never go over 70 or 80 degrees centigrade, and there probably isn't any need to calibrate it to a higher temperature. And so you just measure the temperature with a thermometer, and you put that in the degree box here, and it will also show you the current temperature, what the system thinks is the correct temperature, and the millivolt reading. And then you can just, when you hit apply, it is stored into the memory, and you do that the low and the high point, and that calibrates your system thermocouple for another year.
Yeah, so here it's really simple. 0.1 is your low temperature. You enter it in, hit apply, select 2 for the high, enter in your temperature and hit apply, exit, done.
Right.
Super easy.
Actually, I think you hit the process. It's actually
process, right?
the process button. That's your right.
Right.
Yeah.
And this is just kind of a little overview of the automated extraction and concentration. This is a PLE, and it's just showing delivery from the extract directly to the SuperVap concentrator for final blowdown, and this can be done on any of the solid phase extraction systems as well as the sample cleanup. So this is just a little schematic showing you how it's delivered here and then blown down to its final, volume with this sensor. So again, here, I mean, the key thing is you put that sample in, you have all your solvents loaded, whether it's PLE or SPE, solid phase, automated solid phase extraction, or a sample that's going to be cleaned up for, dioxins or EPH or PAH, pesticides, etc. You're just going to hit run, and it's going to go through the process, never being touched or exposed again to the lab environment, and it's going to be automatically delivered and go to final volume in the SuperVap. So super high throughput when combined with other FMS equipment, the cleanest environment that you could have to do extraction and cleanup. Also the fastest because you're not having any human intervention. No errors either. Rude, I'll let you.
Yeah, we have some data from recovery testing that we did with the different evaporations, and so very good recoveries here, between 75 and almost 100% for just linear alkanes going from nonane to C36. So you can see there's very little evaporation loss here with these the SuperVap heating. Yeah. Yeah.
Get it crazy.
Same here for PAHs. Very good recoveries for evaporation, all in the 80s and 90s. So few losses in the evaporation step.
And this is a PFAS, and this is a 537.1 drinking water method.
Yeah, so here we have done the evaporation, everything is brought to dryness, and then you measure it, and as you can see again, there is not much loss in the evaporation step. All the recoveries are basically about 85% or higher, up to about 110% or so, and at 15%. This is just to show that there is very little background contamination from the SuperVap PFC. As Tom said, you can run that either if you want with glass vials or with polypropylene. I think polyethylene vials, 15 milliliters.
Yeah, but polypropylene and what they prefer. Glass is for other methods.
That we have elaborately tested, and also their good recoveries, and this is for 533, and you can see the error bars are good between replicants, also recoveries at 80% or higher.
Okay, so the SuperVap in summary, we'll cover the points and then we'll answer any questions on the chat. It's a waterless dry bath, dry heater assembly, which provides robust operation and no water dripping into the vessel from condensation. It comes also with covers for the tubes if you're concerned about that running in a humid, lab environment, and also those can be used for if you're running very high concentrated samples. It will help eliminate any possibility of contamination crossing over from tubes. It's fully automated. It can be, hit the run. It's going to be either using the sensor or it'll stop at a time. It's compatible with all FMS automated systems. All the folks that have our automated extraction and cleanup systems, we highly recommend that this is, the system is attached to that for a fully automated sample prep workflow, and that's how most of the folks that have multiple portions of our sample prep run them. So, sample handling, we have all different sizes and shapes and forms of these to handle the market. The direct to vial is really kind of a big deal, especially if you're working with very sensitive types of samples where you're losing, you have losses between transfer steps. It's going to reduce those errors and you're going to get better recoveries. That's just a fact. And then you have your automatic endpoint detection and nitrogen shutoff for each vessel. That's really important so you're not wasting nitrogen. And then you have timed endpoints as well. Again, I just talked about this. You have a lot of different, models and vessels to cover the complete range. Actually, I don't have the 15 mil centrifuge tubes in there, but it does cover those. That's the PFAS concentrator. So again, it's easy to use. It has the smallest footprint of any concentrator or concentration family in the industry. Our glassware is inexpensive. A lot of folks' glassware is super expensive. We're almost 50% less as far as the cost of that goes. So this can be run standalone or integrated. So even if you have an automated system and you have it hooked up, the SuperVap hooked up to our system, it can be run standalone for other types of, evaporations that you're doing in your lab that have nothing to do with solid phase extraction or pressurized liquid extraction, and you may need to do some types of blowdowns. It's going to produce consistent, reproducible results, and it's going to reduce your errors. So with that, we'll take any questions. I'll go up to the chat. Okay, it says, is it possible to set some tubes in the automated mode or some in the manual? I'll defer to Rude on that one because I do know how to run it, but I don't run it every day. So Rude?
I think it's either automated or, and so like Thomas said, if you run manually, it won't have the alarm function. It is timed and it will just.
Well, no, with the switch, like with the switches in the previous version, you could set it to automated or manual. You can do that. And it's with the actual, yeah, you can do it the same way. You're deselecting or selecting let me see if I can get back to if I can actually, down here, if you can see, this is where you're turning it on and off manually. So if you have that deselected, everything here right now is in manual mode, correct, Rude? Yeah.
Yeah, right now.
So this is where you would do it. You could just select it off, leave your other vessels running in the automated mode. So that's how you would do that. I hope that was clear, Max. And you're right, it's possible with the switches, and it's possible. These selections are now your switches. It's much more easier than having all those switches all over the place. You have this nice big screen now. There's somebody who's evaporating hexane around 60 mils in sensor mode. They want to wait for the alarm to indicate that the volume is achieved, or can we say approximately 40 minutes, because the customer always wants to know the time taken to evaporate. Yeah, I mean, that's kind of the way you do it with the, you know what the temperature is and what volume nitrogen you're blowing down. So by knowing those two types of things, you can set a time, for example, to 35 minutes or something like that. And we'll stop at 2 or 3 mils, right, Rude? And then you can go ahead and go to sensor mode after that. And it should only be a few minutes.
Yeah,
I mean, you can do that. I mean, but with like PFAS and PFOS, you're kind of doing more walk-away things. So you know that evaporation is on the fast side. That evaporates methanol, and if there's a little bit of water in there, for example, it's going to be an hour or longer. So you would set the time to 55 minutes, for example, on those 24 samples or whatever, methanol samples. And then when you come back, it's going to be at like 1 or, 500 microliters or something like that. And then they start to watch the sample for the last, 500 microliters of that blowdown. So yeah, that's how it's meant to be used, so that if you do want to do something like that, you can do that. And if anybody needs help with those types of setting up those types of methods, you can send us the version of your software, even for the existing SuperVaps, and as long as we have the software version and the file, Rude can definitely, fix those things for you or set them up for you. Okay, everyone. Well, thanks for attending, and we will be sending the presentation out to you shortly. Have a good day.